So we are going to be doing piecewise, graphing piecewise. And what I like about this name is what you're doing is you're wisely piecing 3 graphs together to make one graph. These 3 separate lines will make one function f. And you're wisely piecing them together. This thing right here, these little information at the end of each graph, like this graph is for this interval, values less than -2. We're going to graph this graph for values less than -2 of x. We're going to graph 4 for the values from -1 to 1. We're going to graph x for the values greater than 2. So we're graphing 3 separate graphs, but only pieces of each graphs on separate intervals. It's a little weird. You'll get used to it. So here's how we're going to start it. What I want you to first do is we're going to graph this, but all we're going to do is put dots. Don't put the actual line between them. We're going to put a whole bunch of dots, and then from there we're going to put the graph to where it belongs. So I'm going to start off. I'm going to make this first one blue. So I'm going to put a little blue dot there. You can't do that. But what I'm going to do, this graph says we are going to start at 5, and we're going to go up 2 over 1. Hopefully you know that. We're going to start at 5 and go up 2 over 1. So what that means is I'm going to go over here. I'm going to put a dot at 5. Now if I go up 2 over 1, wouldn't it be up here somewhere? So let's go down 2 over 1 and go the opposite direction. So are you okay? There's a dot there. Are you okay? There's a dot there. A dot there. A dot there. And a dot there. Are you okay? That would be the graph of 5 plus 2x. Starting with 5 and adding 2x. Slope of 2. Now it's interesting. We don't connect the dots. We only want the graph on this interval for values less than or equal, just less than -2. So I only want the, look at this graph, isn't this the x-axis? So I'm going to start here at -2, and from this point on is where I want my graph. So here's how it would look. At -2, I'm going to put an open circle, and then all I'm going to do is graph it for that interval only. I do not want this part of the graph. See those dots there? Those dots basically could be erased. Don't even worry about erasing them. They're not part of the graph. They were just used in order to get this graph. So all I did is I graphed this function for values less than -2. See how didn't we graph a piece of the graph? Piecewise. Not the whole thing, just a piece of it. The second part tells you what piece. You know, if that was greater than -2, wouldn't you be graphing this part? It all depends on what piece it's telling you to graph. Now, why do you think it might be an open circle? Because it's just less than. If it was less than or equal to, guess what? Closed circle. The edges depend on greater than, less than, greater than or equal to, less than or equal to. You'll get the hang of it. So let's do another one. I'm going to do the second one. This right here, and I'm going to do it in red. And what you're going to notice is this one's kind of weird. Do you understand there's no x? This is y equals 4. So there's no slope. The slope is 0. Do you remember that a graph y equals 4 is a horizontal line at 4? So I'm going to start here at 4, and put some dots at 4 right here. And put some dots for that. And I'm going to keep putting these dots here. Okay, it's a flat line at 4. But what interval does this tell us we're going to graph? From -1 to 1. That's all we want. That's the only piece of it we want. We don't want anything but that interval. From -1 to 1. So what I'm going to do, can you tell that's a closed circle to an open circle? From a closed circle to an open circle. So I go to my graph. I'm going to start at -1. And we said it's a closed circle, so I'm going to drastically make that kind of obviously closed circle there. And at 1, I'm going to put an open circle. Kind of make it a little drastic just so we can for sure see what's going on. So that is a graph of 4, but only from -1 to 1. So that's the only piece of it I want. So I got this piece in blue for the first graph. I wanted this piece for the second graph. And now I'm going to do one more graph here in a second. So for our last graph right here, you might want to think of this as, let's get the black here. Y equals x plus nothing. If you want to squeeze that in, are you okay that you might want to think of x as x plus nothing? It might even help to put a 1 in front of that x. Is that okay? Because your slope is 1. So what that's saying basically is start at 0, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. There's the graph. But what piece of the graph do we want? We want it for values greater than 2. So I go to 2, and do you see how it's going to be an open circle? Because it's not saying or equal to 2, it's saying greater than 2. And then I'm going to just graph my line to the right of that, because it's saying greater values than that. So that is my last graph. Do you see now how we piece together 3 graphs to make one singular graph that looks kind of weird? Okay, so like for instance, you are gaining your money. See how steep this is? So your money is increasing, and then all of a sudden, oh, it's a flat grade, and then oh, it goes down to here. It's kind of the dumb application. Ignore that. Now, for domain and range, it's going to get a little tricky. Actually, before we go to domain and range, I want to write something down. I want to write down just that this might help. Oops, that might help to do that too. If I have this or this, is that open or closed? Open. Are you okay that's open, like an O? Dots. And if I have this or this, what is that? Closed. You have a nice solid closed dot. Great handwriting. Closed dots. Closed dots. It doesn't look very good if you looked at it later. Okay. Open versus closed dots. Make sure you got that. But we're going to domain range. Domain, if I look at my graph right here, domain is what x values are on this graph. As I go across this graph, where do I have a graph and where do I not have a graph? So as I go across, can you tell the graph is missing right here on this interval? Can you see how there's no graph right in that interval right there? As I keep going, do you see how there's no graph right there? So my domain is lacking in this little interval and in this little interval. But everywhere else, do I have a graph? As I go across, you see I have a graph. It's blue. Oh, stop, nothing. Okay, now it's red. Oh, now nothing. Oh, now it's black. And that's what it's kind of asking for. So if I want my domain, what I'm going to say is basically for my blue function, aren't we going values less than -2? So it's going to be x is less than -2. All right, that's part of it. Then we're going to go to my red function. Won't that be from what, -1 to what? 1? Okay, then let's go to my black function. Won't that be from values greater than 2? As you look at this, for my blue function, aren't it values from less than -2? Then we're missing for a little while. Nothing's there. There's no graph in this interval. Then we start up again from 1 to -1. And then we start up again from x larger forever. Those are my domain. Now there is a notation you might like better. You could write it this way. Ready? Do you guys remember this notation? It's called interval notation. You could write it this way, even though some of you might not like it. You can write it that way. Comma. So this should be a bracket. From -1 to 1, that's a parenthesis. And from x to infinity. This is another notation called interval notation. You could use that for domain and range, or you can use these things. We talked about this on another section. But again, this is saying the same thing. This and this are the same thing. Values less than -2, that's saying from -infinity to -2 is the same thing. Do you see how it's an open bracket? Because it's not or equal to. See here, see how that's or equal to? See that's a bracket where this is a parenthesis? And look at this one. Do you see how that goes to infinity? Infinity, by the way, do you understand infinity wouldn't be a bracket? You can't close infinity. Infinity keeps going, so there's always an open parenthesis. Anyways, you'll get used to it. All that stated, let's go to range. Look at your graph this way. As I go up my graph, do you see how from here to this point is it blue? As I go up, I just want my finger right here. As I go up, do you see how the graph is blue? Blue, 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 blue. Then did the graph all of a sudden stop? Do you see how there's no y values right here? See the y values are lacking? But then, from here on, isn't it black? Now the red is there, but doesn't the black take care of the red? Like it has two functions, two values. here and here. But basically, from this point on, don't we have a graph? So range is basically saying you're going up. Oh, no graph. Okay, now we have graph again. So if I want to write down my range, it's going to be values less than 1. Can you see how this blue graph is values less than 1? And the black graph is what? Values what? Greater than 2. I have to take something back. This is a y. It's pretty important. Range is your y values. And this is a y greater than 2. If these were closed circles, wouldn't those be or equal to? So that right there is fine. You could also write it in this interval notation, which would look something like this. You could also write it like this. It'd be negative infinity to 1 and 2 to infinity. So that would be interval notation. Either one's fine. Whatever you get familiar with is best. For the last piece, I want to know f of negative 3. It's basically saying, what is the value at negative 3 for my graph? So at negative 3, at right here, what color is my graph at that point? Yeah, so what's the value? Negative 1. So my answer is negative 1. Now, what if you didn't have the graph? How do you find the value? Well, if we didn't have the graph, could you just look at this? If this is all you're given, on which interval is negative 1? Can you tell by looking at it? Do you see how negative 1. Negative 3. Take it back. Negative 3, right? That's what we're looking for? For which of these functions is negative 3 on? Is it the first, second, or third? Isn't it part of the first? So you just take that function and plug in negative 3. So I would take, okay, 5 plus 2x, and inside of x you're going to put negative 3, and watch. Do you get negative 1? Do you see how they're the same? So if you weren't having the graph to look at, could you simply look at the interval to see what number to plug in? For instance, what if I wanted f of, this is not part of your notes, but what if I wanted, what's f of, say, 0? Could you look at the graph? At 0, what's my value?
5.
Is it 4? Could you also go and put 4? Isn't 0 in this interval? If I put 0 into that, won't it be, what's 0 times, wait, there's 4. No matter what you put it in, is it always 4? So you can look at the graph or you could plug it in. That was a bad example because you can't put 0 into 4. But you hopefully get the idea.